Welcome to this presentation for IFR pilots. I'm Bruce Williams, a flight instructor based in Seattle. You can find more information about me at my website, blog, and YouTube channel. I get many questions from pilots about how they can use an IFR-approved GPS while flying departures, airways, arrivals, and approaches that are based on or include navaids, VORs, DME, localizers, and sometimes even NDBs. The guidance from avionics handbooks, instructors, and FAA publications isn't always easy to understand, so let's see if we can sort out key details through a close look at specific examples. Let's begin by looking at a typical ILS approach. This example, the ILS or Localizer runway 17 at Tacoma Narrows, requires only one navigation receiver, although using a single nav radio would be a challenge. But you don't need DME, ADF, or RNAV equipment to fly this approach. For example, you could use VOR to fly the feeder route defined by the 227 radial from the Seattle VOR to SIN. Then intercept and track the localizer outbound to fly a procedure turn. Next, intercept and track the localizer and glide slope inbound, identifying SIN either with the Seattle 227 radial or the outer marker. And, if you go missed, climb and fly a heading to intercept and track the 227 radial inbound to hold at SIN, a fix defined by the intersection of the localizer and the radial. But if you have a suitable RNAV system, or to use current terminology, a navigation system approved to fly RNP approach procedures, you can use that system for guidance to fly every leg of this procedure except the final approach course. You could fly the magenta line to track the feeder route, then follow GPS guidance outbound for the procedure turn. Switch the primary CDI to the localizer to fly the final approach course, because, as we'll see, you must use the localizer for primary guidance on the final approach segment. And then, if you go missed, switch back to GPS guidance for the return to SIN and the published hold. Here's what that sequence looks like if you fly the approach with a GTN 750. Note again that all of the legs of this ILS approach are shown in the active flight plan. After you fly the feeder route, the GPS provides guidance outbound for the procedure turn, and back inbound toward the final approach fix, as you can see on the PFD. As you intercept the localizer inbound, switch the primary navigation source and CDI to green needles, the localizer. Use the GPS to verify your position relative to any step-down fixes, and the runway or missed approach point if you're flying the localizer-only procedure. If you go missed, you can return to GPS guidance all the way to the published hold. Note that the first leg of this missed approach procedure is a heading leg, a climbing right turn to intercept a radial inbound toward the Seattle VOR. But as you intercept the 227 radial, you can follow GPS guidance to return to SIN and enter the published hold. With a WAS-capable navigator and an autopilot with GPSS capability that can follow curved paths, the autopilot can fly the entire procedure, including the missed approach hold. Now, before we go too much further, let's note the requirements for a suitable RNAV system, the FAA's current term of art for avionics that support RNAV under IFR. The details are in AIM 1-2-3 and AC 90-100A, and the cross-references in those documents. These references describe the specific requirements for avionics that you can use for RNAV under IFR. Several types of navigation systems meet the requirements described in the AIM and ACs. For example, the multi-sensor FMS boxes common in business jets and airliners typically use multiple VOR and DME inputs and GPS to calculate the aircraft's position. Inertial reference systems, today found mostly in airliners, also may meet RNAV requirements. But for those of us flying typical light GA aircraft, suitable RNAV system means an approved panel mount GPS or GPS enhanced with WAS. The Airplane Flight Manual, or AFM supplements for the avionics installed in your aircraft, explain the approvals and operating limitations for the units in your panel. For example, here's an excerpt from the AFM supplement for the Garmin GTN series. You can also find information about the approvals for many, usually older, systems in the AC 90-100 compliance tables, a PDF that you can download from the FAA website. Official guidance for using these systems under IFR is in the AFM supplements and currently in AIM 1-2-3 and AC 90-108. The text in the AIM and AC is essentially identical. That guidance essentially boils down to these items, although as we'll see later, a legal and technical issue related to localizer courses remains. For example, you can use GPS to determine your position relative to a VOR, NDB, DME fix, or a named fix defined by VOR radials, NDB bearings, a locator outer marker, and so forth. And you can use GPS to fly courses defined by VOR radials and NDB or locator outer marker bearings, or to hold at a navaid or DME fix, and to fly arcs based on DME. A note at the end of the list specifically allows you to use GPS even when a procedure includes a note such as ADF or DME required. For example, if you have a suitable RNAV system based on GPS, you could use GPS to identify, navigate to, and determine distance from all of these elements of a conventional approach, in this case the Localizer runway 31 Yankee at Salem, Oregon. Load that procedure into a navigator like the GTN 750 or G1000, and you see this sequence of fixes. You could also use GPS to fly the DME arcs on this VOR approach at Payne Field, north of Seattle. Most of us no longer have DME on board, but we can fly the published arcs using GPS. The DME arcs are just legs in the procedure, flown like any other feeder route or flight plan leg. Here's how one of the DME arcs appears in the flight plan when you load that VOR approach. Of course, as we'll see, if you're flying a VOR approach, you must have the VOR tuned, and you must reference it with a CDI or bearing pointer as you fly the procedure. But there's no requirement to enter the VOR as a waypoint for determining DME distance. In addition, according to the AIM at AC 90-108, if you have an IFR-approved panel mount GPS, WAS or non-WAS, you can essentially ignore notes related to DME or ADF and DME. The examples we've seen so far show the two key concepts that govern the use of GPS when flying conventional routes and procedures based on navaids. The first idea is substitution. In general, substitution means using GPS or another RNAV system instead of ground-based navaids, such as when a navaid is out of service or your aircraft is not equipped to use a navaid, such as DME or ADF. In this sense, substitution is a procedure when you want to fly an IFR route, departure, or approach, and a required navaid isn't available. Alternate means is an optional technique that you can use when you could fly a procedure using navaids, but you choose instead to use GPS to supplement working navaids. These terms aren't called out as clearly as they should be in the AIM and other guidance, and sometimes the distinction between them is subtle and the concepts may overlap. But here are some key points. Again, substitution means using GPS as the primary navigation source when a navaid is not available. For example, NOTAMs may require you to use substitution when a VOR or locator outer marker is out of service. Substitution also applies when your aircraft does not have equipment such as DME or ADF that may be required to fly a given procedure or route. Alternate means of navigation is usually a pilot technique. For example, using GPS to fly a VOR-based airway or to fly a departure, arrival, or approach based on one or more navaids. Alternate means requires that the navaids are working and that you may, or sometimes must, monitor the navaids with a CDI or bearing pointer, as we'll see later. For example, today most of us fly Victor Airways with GPS. If the VORs that define the airway are working, and the route has not been made invalid by a NOTAM designating it as unusable, Flying a Victor airway via a magenta line is an example of using GPS as an alternate means of navigation. You could follow VOR indicators, but GPS makes navigation easier, especially if you're using an autopilot. However, if one or more of the VORs that define an airway segment were out of service, we could, with some limitations, still substitute GPS for the VORs and fly the same routes. Here's an example of a NOTAM that renders several airways not authorized unless you have an IFR-approved GPS. Per that NOTAM, you can still fly these routes by substituting GPS for the out-of-service VOR. Or, to return to the ILS at Tacoma, using GPS to fly the legs of this procedure, except the final approach segment, is an example of using GPS as an alternate means of navigation. The navaids are working and you have the equipment on board, but you opt to use GPS to navigate until you reach the final approach course, and then again to fly the published missed approach and hold. Here's an example of using GPS both as a substitute and as an alternate means of navigation on the ILS runway 13 right at Hillsboro, Oregon. In this case, you don't have DME, so GPS substitutes for DME so that you can fly the arc and identify step-down fixes along the final approach course. GPS is also a complement to working navaids that you could use, but using GPS as an alternate means of navigation greatly simplifies setting up for this busy procedure, which would otherwise require tuning and switching among multiple navaids. If you load this approach, all of the fixes that define key points on the chart are available in your navigator. For example, you don't have to identify and keep track of fixes defined by cross radials, switch the nav2 source for the miss, and so forth. A close look at the profile view shows several fixes defined by cross radials and DME fixes. And here's how the fixes appear in the flight plan, easy to reference with GPS. There is, however, one detail to consider when you fly an approach like this. Both the ILS and the localizer-only procedures appear on the same chart. But one fix, JICM, applies only to the localizer approach, and depending on the database that you use, that fix appears in the waypoint list only if you load the localizer runway 13 right approach in the navigator. It's important to confirm that you load the correct procedure into the box, and then, when you brief the procedure, confirm that the correct sequence of waypoints appears in the flight plan, so that you don't expect to see a fix, usually associated with an asterisk note, when it's not part of the procedure, or so that you can plan to meet a critical altitude restriction when you are flying a specific variation of a procedure. Another variation on the concept of substitution is often spelled out in NOTAMs when a navaid is out of service. For example, here are NOTAMs that were issued for Arlington, Washington. The text departure procedure at Arlington relies on the Watton locator outer marker. If ATC clears you to fly the text DP, you could build it into your GPS and fly it. Just be careful about how you set it up, and be especially aware of heading and course to altitude legs. In particular, don't make the common mistake of going direct to a fix too early, and make sure that you carefully brief and use autopilot modes correctly. And here's a similar NOTAM. The text specifically requires an IFR-approved GPS, not just any suitable RNAV system, for example a DME RNAV system and an FMS, if you want to fly the ILS at Bremerton. GPS is a substitute for the Seattle VOR, a required part of the procedure if you don't have DME, and you choose to fly that procedure. A similar NOTAM requires an IFR GPS to fly the ILS or Localizer 14 right approach at Boeing Field. Let's divert for a moment and consider departure procedures in more detail. Here's a charted obstacle departure procedure at Coeur d'Alene, Idaho. This conventional procedure requires only a VOR receiver to intercept a radial after takeoff and track it outbound while climbing. Then turn back direct to the VOR, intercept a radial to CARPS, and finally proceed on course. All of the action takes place close to the VOR, located on the airport, and VOR needles are twitchy when you're close to the station. Flying this departure with only a conventional CDI is a challenge. Flying this departure procedure is much easier if you use GPS as an alternate means of navigation. Load the procedure in the box and you'll have stable GPS courses to fly. If your navigator receives altitude inputs, and if you have an electronic HSI, life is even better. You see reminders of critical altitudes, and new courses appear as you climb to the charted intercept altitudes. You don't have to twist courses on a CDI, identify a distant second VOR or use DME to confirm CARPs, or switch primary nav sources as you join an airway en route. Of course, if I were flying this procedure with GPS, I'd still have the Coeur d'Alene VOR tuned and set up with a bearing pointer for reference. However, if the Coeur d'Alene VOR were out of service, I could still fly this departure with my suitable RNAV system as a substitute, if allowed by NOTAM. To sum up so far, the guidance in the primary references essentially boils down to these bullet items. You can fly conventional departures, arrivals, and approaches using GPS as a substitute for or as an alternate means to navigate the procedures, with certain limitations. Now let's take a close look at the most critical phase of an approach, the final approach segment. For most of us, the final approach segment of a conventional approach is defined by either a localizer or a VOR radial. NDB procedures are going away. FAA guidance for use of IFR-approved GPS along the final approach course has evolved, but confusion remains. Here's the current text on this topic from the AIM and an AFM supplement for the Garmin GTN or GNS navigators. This language allows you to use GPS as an alternate means of navigation even along the final approach segment if you can meet certain requirements. You may fly the final approach segment of a VOR approach, like this example at Payne Field, using GPS to track the course if the VOR is working, you can display and monitor the final approach course on a CDI or bearing pointer, and the approach has not been declared unavailable by NOTAM. Here's what that technique, using GPS as an alternate means of flying the final approach segment on the VOR Alpha approach at Payne, looks like on a modern PFD. The primary CDI is set for GPS guidance. A bearing pointer is set to the Payne VOR to meet the requirement for monitoring the navaid signal and final approach course. And the G500 TXI shows a gray VOR CDI preview for orientation as you fly the arc to intercept the final approach course. This is the view on final. The primary CDI is still set for GPS guidance. It provides lateral steering for the autopilot. The bearing pointer set to the Payne VOR confirms the navaid signal and final approach course. And the G500 TXI shows a gray VOR CDI course for confirmation as you fly toward the missed approach point. This close-up view of the PFD shows the indicators in more detail. If you have a separate CDI, you could also monitor the final approach course to the Payne VOR on that display. Here's a similar setup for the VOR runway 35 approach at Olympia, Washington. The primary CDI is set for GPS guidance. A bearing pointer is set to the Olympia VOR to meet the requirement for monitoring the navaid signal and final approach course. And the G500 TXI shows a gray VOR CDI preview for orientation as you fly the arc to intercept the final approach course. And here's another close-up view of the PFD, showing the primary CDI set to GPS, a bearing pointer set to the Olympia VOR, and the gray preview offered by a G500 TXI. This technique for flying VOR approaches, the same setup could work for an NDB approach if you have an ADF, is supported by the AFM supplement for the Garmin GTN series and GNS series navigators. For example, here's an excerpt from section 2.9 of the AFM supplement for the Garmin GTN 750XI. Identical language now appears in the AFM supplements for the earlier GNS series navigators. Here's a closer view of that text. But remember that as the AIM notes, you cannot substitute GPS for the navaid signal. If you're flying one of the increasingly rare or GPS, VOR, or NDB approaches, you can use GPS instead of the navaid, but in that case you're flying a procedure designed with GPS or a navaid in mind. Except for or GPS procedures, the primary approach navaid must be working, and you must monitor the final approach course on a CDI or bearing pointer tuned to that navaid. And the approach must be valid. It cannot be not authorized by NOTAM, such as when a new obstacle or failure to pass a flight check requires recertification of the procedure. But let's return to the language in the GTN AFM supplement. Note the specific limitation about flying the final approach segment of a procedure based on a localizer. Let's take a closer look at these distinctions related to localizers. First, remember that localizers are angular courses that narrow as you approach the runway threshold. On final approach, the obstacle clearance surfaces are based on that ever-tightening localizer course, and the wider 0.3 nautical mile GPS courses in the terminal phase don't guarantee obstacle clearance as the course narrows, except when flying an approach with LPV or LP minimums. So the AIM and other references in effect require that you use the localizer for primary guidance when inbound on an approach. Note also the phrase without reference to raw localizer data. The preceding text seems to allow the use of GPS to complement a localizer during the initial stages of an approach and while flying a departure or arrival. For example, the Kent 8 SID at Boeing Field involves flying the back course of the ILS runway 14 right. Of course, today you'd fly the corresponding RNAV departure, but for the sake of argument, you could load the Kent 8, perhaps to fly an IFR departure off runway 14 left, and fly it with GPS guidance while monitoring the localizer on a CDI. You're not flying the localizer inbound to a runway, with the course narrowing as you go. Here's what that departure looks like when loaded into a GTN 750. Here's what the PFD shows with that SID loaded. You can't use a bearing pointer to monitor the localizer course, so you'd need a separate CDI to meet the letter of the AIM language. In this case, the departure is designed primarily to keep you on a track that avoids conflicts with traffic at nearby Seattle International Airport. And following GPS guidance provides a more accurate, consistent track than that offered by a localizer, especially immediately after takeoff. You also don't have to switch primary nav sources as you transition to the en route phase of flight. On a departure, you're flying outbound and climbing, and the departure procedure uses specific obstacle clearance criteria not tied to a narrowing localizer course, as on an approach. Still, this use of GPS seems to be a gray area, at least according to the current text of FAA guidance. But I have never heard of it causing an issue with ATC, and if you brief and confirm your plan, I've never heard of it causing an issue with a DPE on a practical test. Fortunately, clarification may be coming, although not immediately. FAA is working on a new AC that will combine guidance from several existing ACs and clarify, in particular, the use of GPS and other suitable RNAV systems to complement or substitute for a localizer. This AC is still in development, and it may not be available until 2023 or so. Don't hold your breath. Finally, let's review some odds and ends related to using GPS on conventional procedures. Visual descent points are not in procedure databases, and you won't see them in the list of fixes when you load a conventional or RNAV approach in a GPS navigator. If a VDP is available for a non-precision approach and you plan to use it, brief how you will identify that fix. A long track distance arithmetic may be required, usually referenced to the runway threshold or missed approach point. In general, don't worry about the difference between DME slant range and GPS distance. See, for example, AIM 5-3-8 holding. When you use GPS and there are named fixes along the final approach segment, you may have to do some arithmetic to confirm your position relative to the missed approach point, as described in the AIM. Here's an example of that situation as shown by the profile view of an ILS at Salem, Oregon. Note an often overlooked limitation on non-WAS GPS. The AIM states that if you're using a non-WAS receiver, ground-based navaids along your route and at your destination and alternate must be operational, even if you don't intend to use them. The AIM also addresses confusion about differences between the courses displayed by GPS navigators and charted courses based on navaids. The basic issue is that GPS systems calculate magnetic courses using various algorithms and magnetic variation models, chartered courses are established using a different set of criteria. As the AIM notes, the differences are typically only a few degrees, and a suitable RNAV system will fly the correct track. Nevertheless, you should monitor your progress with all available means, including bearing pointers, CDIs set to navaids, and a moving map. Back to using GPS to fly Victor Airways. If the airway, or a segment of the airway, has been rendered unusable by NOTAM, you can't fly the airway, even if you have GPS. Unusable means that the route is no longer valid, perhaps due to obstacles, airspace, or ATC limitations. Here's an example of an unusable airway segment. The only legal way to fly this track is via ATC vectors or via a point-to-point route defined by named fixes. Finally, FAA has started publishing conventional procedures that require RNAV. For example, this ILS at Billings, Montana requires RNAV to fly the charted feeder routes. Here's another example, an ILS at Reno. This approach includes a transition that requires RNAV, and the entire missed approach is defined by RNAV fixes and courses. These procedures aren't common, yet, but expect to see more of them as more VORs are decommissioned and as we transition to performance-based navigation. You may have noticed that I use a color coding scheme to annotate IFR charts. The process of annotating charts ensures that you review procedures during pre-flight planning, and the color coding reminds you of when you'll use GPS and when you'll switch to green needles or fly headings. This practice is especially helpful when you plan to use GPS during a conventional procedure. For example, here's my markup of the chart for an ILS approach at Sheboygan, Wisconsin. Magenta lines and boxes show legs where I will use GPS. Green lines correspond to legs flown with green needles, such as localizers. Green boxes highlight VORs and other navaids that I can tune and use for reference during the approach. Blue lines indicate heading legs. Red boxes highlight minimums and other critical information. To learn more about annotating electronic charts, see my separate presentation devoted to that topic. It's available on my YouTube channel and via links from my blog. You can find more information about all of these topics at my website, blog, and YouTube channel.